Namaskar and welcome to episode number 3 of Understanding Feynman's Physics podcast. Look, we discussed yesterday about the first, second, third, and fourth laws of electromagnetism. We just decided to state them without understanding. So today I went back and tried to understand. And I realized it's a little mathematical. It's not that easy, but I try to make sense of it. I try to remember what I learned in my childhood. I try to understand through various, not various. I read a couple of websites. That's all. Nothing much. So let's go through the 4 laws. First of all, there is a very interesting website called Maxwell's equations.com, which has very interesting way of explaining, very nice way of explaining. And I realize it's a little mathematical, but I won't go through all the mathematics, of course, because I didn't understand much. But I kind of got the crux of, or I think I got the crux of, or the central point of all 4 laws. And let's go through them. The first one is, so first of all, I should tell you about the Maxwell's equations, which now Feynman doesn't talk about Maxwell because his book and his lectures were actually a lot about recreating the physics in front of the students, basically just trying to show that what kind of phenomenon gave rise to what kind of thoughts and what kind of understanding, and that's very interesting and fascinating to follow. But I diverged from that point of view because it's I am really interested in Maxwell's work as well. And I'm really interested in electromagnetism because of other reasons as well. So I decided to diverge a little bit, and I'll talk about things that Feynman doesn't talk about. So understanding Feynman's physics may be not the right name for this particular episode, but that's fine. It's fine. Equation 1 is Gauss's law. Equation 2 is Gauss' magnetism law. Equation 3 is Faraday's law, and equation 4 is Ampere's law. As you realize, and as I realized, that all these 4 laws are by different people. Well, first and 2 are by Gauss, and second is by third is by Faraday, and the fourth is by Ampere. What Maxwell did was to understand that all these things, all these laws actually go together, and he kind of joined all of them under his, under one umbrella. Apparently, that's what I understand. So the first law, we discussed it yesterday. First law is the Gauss law, and it says that actually what it says is simply that if there is a charge, if there is an electric charge, it acts as a source or a sink for electric fields. That's essentially what breaks down intuitively. If you have a charge, if you have a surface, if you have a closed surface, think of electric field as water flowing, right? That's easier and more mundane to understand, and for this, that analogy works. For this understanding, that analogy kind of works. So if you consider that there is a closed surface, take a closed surface, a ball, right? And let's say there is a water outlet in the middle of it, in the middle of that closed surface, inside the ball. There is a water outlet. So the amount of water that escapes that surface the amount of water that escapes that surface, that escapes that ball, would be proportional to the strength of the flow of water, right? The stronger is the flow of water, the more water will come out of that surface. Very simple, right? And that's what it is. If there is a very small flow of water, very tiny, the flux of water would be less. It's called flux. Flux is the term that we defined yesterday. And we can think of it as I think of it as, I personally think of flux as the strength of things flowing through a surface, a flux. We use it in other forms of communication all the time, and that should inform us about the nature of this world. And we'll go through, as we go through the book, we'll understand more about it. That's the first law. The second law is about magnetism. Now, since childhood, I've played with magnets, and I was fascinated by the fact that there is always two poles of a magnet. A charge can be either a positive charge or a negative charge, and there can be a single particle with one charge, right? But magnetism doesn't work like that. Magnets have both charges, both poles together. There is no unipole, right? There is no unipole. So the magnetic flux that can come out of a ball will always be the same as the flux that comes into the ball. That's always going to be the case, because the source and the sink of the flow of water, magnetic water field, is north and south pole both have to be together. So in a way, the source and the sink are together. Even if some water flows out of that ball, the same amount of water will be coming into the ball, because the source and the sink are of the same strength, right? They are dipole, So, because magnetic monopoles do not exist. That's the reason. So, first law was electric law. Since a charge can be a mono charge is possible. For electricity, electric charge, flux coming out is the amount of charge inside a surface. But the magnetic flux coming out is always zero. The amount of flux that comes out is the amount of flux that goes in. That's the second law. Now the third law is about the fact that a changing electric field will cause a magnetic field, right? A change in electric field will create a magnetic field. Or is that the other way around? Both are true. One of the laws is this, that and there are multiple ways of showing it. Faraday has shown it in a different way. We might look at it tomorrow, because it's already 10 minutes are up. This is the beauty of 10 minutes. You don't have to go for long, and if you're confused, you can just stop. I am really confused here. I'm still confused. I'm not able to give enough time to it because it's every day, but I think 10-15 minutes is fine every day, and we can achieve a lot more things. So apparently this is the third Maxwell law. I'll just read it from the Maxwell's equations. On this page, we'll explain the meaning of the third Maxwell equation, the Faraday's law, which is given in equation 1. Ulta delta times E is equal to minus of change in magnetic field. So what they do is, it's actually the workings of the insides of um, a what's that? The transformer, transformer coils. There are two separate circuits, and there is a magnetic. There are two coils. One is attached to a battery, and the other side is attached to an ammeter, which calculates the current flowing through the wire. And there is no source of battery, or there is no electric source attached to the second coil, but both coils are attached together only magnetically. A current cannot flow from one to the other, but magnetic field can flow from one coil to the other coil, because there is a magnetic core, iron core, in the center of that's running through both the coils. There is a ring of magnetic core. One coil is wrapped around one side of the core, one side of the ring, and the other coil is on the other side of the ring. And if there is a battery on the coil number one, which is creating a moving electric field through the coil, that will create a magnetic field which will flow to the second coil, and the second coil will, because the magnetic field goes to the second coil, it will create a current in that coil. That's the nature of, that's how a lot of things work in electrical appliances. I think the motor, the DC motor, does the DC motor work? The AC motor, I think, works like that. Transformers work like that. I think that's why they require alternating current, because alternating current always keeps changing. The electric field always changes, and that creates a magnetic field, and then that magnetic field is used to create electric field in another place. We'll look deeper into these laws number 3 and 4 tomorrow, and I think today's podcast betrays my lack of deeper understanding of this subject. Maybe I'm not suitable to teach anyone yet, but at least I can discuss my own lack of understanding of this subject. But there's some hope. There is some hope. I'll figure it out. I'll look through. I'll see you tomorrow, I guess. Bye bye, Tata.